So we need to averaging over all the alignments, those things we need to do. Like so we have done all those things, like we have arranged the table, explicit constraint alignment, like we have taken out all other vocabulary words, just taken the given text values rows and arrange that. If we have duplicates, we will just replicate or create another copy. If we have jet 2 times in the given text, so we have to again have it in the same fashion, such that the alignment, if we will go from like this, from left top to right bottom in this direction, left to right, it will go monotonically decreasing order, like that only we have to do, so that alignment matches with the given text. So all those things we have constructed, and we have run the Viterbi algorithm. So gradients from the alignment we have found here, all those things. I'm just like iterating on the overall process, and this we have explained how this works. So there are two methods. Option 1, determine alignments for every instance, training instance, train model using stochastic gradient descent, or your favorite approach, any optimizer loss function, like CTC loss function, or any optimizer or gradient descent, and on the entire training set, and then iterate. Option 2 is using stochastic gradient descent for each training instance, find the alignment during the forward pass using backward pass. So iterative update, like what is the problem there? Approach heavily depend on initial alignments. What are the initial alignment? It's depend on that, prone to poor local optima. And what are the alternate solution? Do not commit to an alignment during any pass, so just don't commit it. So these are the reasons. So like the reason for suboptimality comes, like we commit to single best estimated element alignment, something like most probable sequence, which we have seen. There are two things, like most probable probability, like each timestamp will just take one. There may be other possibilities also, and this is the another way, like we have to find the most probable path, complete path. But again, both have flaws, as I've said. The most likely alignment, we have found the div over here, and this can be way off, particularly in LA iterations, or if the model is poorly initialized. Alternate view, there is a probability distribution over alignment of a target symbol sequence to the input. So we have the input, we have target symbol sequence, that is nothing but the ground truth values. Selecting a single alignment is the same as drawing a single sample from it, but we have different possible valid paths, so we need to examine that also. So selecting the most likely alignment is the same as deterministically always drawing the most probable value from the distribution, though that's not correct, right? So we need to do something like averaging over all alignments. So instead of only selecting the most likely alignment, we need to use statistical expectation over all possible alignments. So that is what we are going to see now. So that is nothing but something like this we need to do, right? So we need to do something like this. Use the entire distribution of alignments. This will mitigate the issue of suboptimal selection of alignments. So we need to be like thinking about all possible valid paths, all alignments. So for that, using the linearity of expectation, we will get div something like this. This reduces to the finding the expected divergence at each input, something like this, and this calculation are there. So it's like simple mathematics, joint probability of Bayes theorem, like that we will see. So one way of seeing that, as you can see, this probability is nothing but over here, this is nothing but the probability of seeing the specific symbol S at time t given that symbol sequence of S. This is nothing but S is equal to S0 till Sk minus 1 symbols, that those many symbols are there, and given that input sequence x0 to xn minus 1 input sequence, input thing, it's actually nothing but given that actual target symbol sequence for the input is known, conditioning on what we know actually, that's the conditioning thing. So this is a conditioning thing, like given text is there, right, ground truth values, conditioning on that, input sequence is also given, and S is nothing target given text symbols which we have given already in the training set, and at timestamp t whatever the symbol is there on that, given that this actual target symbol sequence and input symbol sequence have been given. So we need to be able to compute this, and this is different actually. This is different from what we have seen, y0 of b, nothing but yt of s of r. This is like probability of that particular symbol occurring at time t, nothing, that's it. This is nothing but probability of seeing that symbol at time t in that particular sequence, entire path, the probability of seeing that at time t itself, given that given text, everything given, input symbol is given and its position has been given in the complete sequence. We have also dealing with sequence over here, but here it's just single individual thing, it's like independent, it's just the probability of its occurrence, word occurrence in that particular time step, given that nothing like it's not conditional. Here it is joint probability or conditional probability, given that ground text values, like ground truth values or target sequence and input symbols, so it comes, everything will come, and that particular happens to be in a certain position or timestamp t in certain row level, like symbol sequence k and timestamp t in the valid path. So all those holdings are there in this equation, whereas it's not there in over here. So understand the difference. So now we will see posterior probabilities of symbols, so that averaging of weights, those things will be also validated, so that we will be equipped with entire situation sequence, not just taking the probability like most probable and going on straight in dynamic programming approach. This is also dynamic programming approach, but we need to think about all valid paths. So this is the total, this thing, this is proportional to this thing, again joint probability, Bayes theorem thing, both are differentiated. Total probability of all valid parts in the graph, for graph is nothing but like this. For target sequence S, valid means all the blue portions which I am showing, like for this example this is not valid for suppose in the problem. For target sequence S that go through the symbol SR, the rth symbol in the sequence S1 to SK, the symbol sequence at time t. So that is the definition for that. Now for example, if you want to calculate, as you can see, ST is equal to SR given target symbol sequence, input sequence, like ground truth values, target symbol sequence. So it's like summation of S0 to ST minus 1, that is nothing but S1 to SR minus 1. That is, I will just show you like this. For suppose if we have this is R in the sequence, for suppose, and we have just one more thing, this is a sequence for suppose. Now what happens is, like this is R for suppose, and like symbol sequence we have 1 2 3 4 and x, this is z x gamma z for suppose, and given text is this itself, z x gamma z for suppose, ground truth values in the training text. So this is the R. So we need to calculate for other things, like we for example R is gamma for suppose. So now R minus 1 means z and x till before thing, and R plus means after this z. So those are the terms which are available in ground text values. If we take whole vocabulary, then before that term itself, before if the gamma is this R term, so R minus will till before, R plus means after that. But if you are just aligning with ground text values, if you are just choosing those rows only, so here for example it will be z and x. If we take R as gamma, R is positioned at gamma in this example, and R plus is after that it will be z. Got it? So this is a symbolic sequence, these are variables and these are the constant something for the example, and this summation is for this, and this summation holds like st plus 1 to sn minus 1, sr plus and sk. So it's nothing but if we are positioned it over here, I'll just erase this one second. If you are positioned over here like this over here,